like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey everybody, still setting up the background. I've changed some mic levels, so hopefully this is all working well for everyone and everyone can see and hear me well. Just listen to the stream from earlier today. It sounded like I was a little loud, so if you guys ever think the video is too loud, too quiet, I'm still setting up everything in here and making some fine-tuning adjustments. So that's got it. But there were questions about the formula sheet. So we have here the formula sheet for exam 2, and I'm going to go over it. And if anyone joins in, feel free to ask questions. So I'm currently live. If you're watching this, hey everybody, I am live on YouTube right now. So we have right here the formula sheet, and we're going to talk about it. So let's do this. Make it nice and big here so everyone can see what's going on. So the first stuff we have right here is probability, and we'll talk over what each one of these means. It's funny because this is kind of a cheat sheet for you right here. This says the probability of the set. This is everything right here. So this is like when I ask questions a lot of times, like what's the probability of making A, B, C, D, or F on the test? The probability of the set of everything is equal to 1. That's what it's saying right here, the set of all possible outcomes. So this is everything that can occur. So when you think about it, the set means all things that can occur have a probability of 1. If you're here, feel free to ask questions. I'm just reviewing the formula sheet so everyone knows when they get it on the test exactly what's on it. So this is the probability of the set of all things. And then we have here the empty set, and this is just like nothing. We don't really talk about that much, but the empty set has a probability of 0. It's things that can't occur. So there's that. And next we get to another big important one, and this one right here is known as the complement. I'm going to add a new highlighter in here. Let's go to highlighter, and let's change the thickness on it. Is that how you change thickness? We'll go to that thickness, and we'll see here. Does the new highlighter work pretty well? That works better. There we go. So this is the complement right here. What I currently have highlighted is the complement, which is everything but the event A. So we can do some practice problems right here. It's always good to do practice problems to know what's going on, because maybe we have the probability of rain, and the probability of rain is equal to 80%. So how could we use this right here to think about what it means? Well, the probability of rain is 80%, and then the probability of not rain, we'll put N rain right here for no rain, just an abbreviation. The probability of no rain is now 20. And this is using the complement rule right here, that we have the probability it rains or it does not rain. So this is the complement rule in action. So that is the complement. That's all that means on the screen right there. We either have A or not A occurring. Next, we've got the thin highlighter right up there. We have the probability of A, and you can do the same. You can find the probability of A from the complement. So this is really just the complement backwards and forwards. This one is taking the not rain. So if you have probability of no rain, we're just going to put, there we go, no rain right here. If the probability of no rain is equal to 20%, well then the probability of rain, it's just going in reverse right here, is equal to 80%. The one I'm currently highlighting shows us, if you jump in, feel free to ask questions, just going through the formula sheet to help out. And so we have the probability of rain and no rain, and this one goes from finding the probability of the event from its complement. So it takes the complement, which is no rain, and finds the probability of rain. And something we should always know about an event and its complement are always equal to 1. So when you have something occurs or does not occur, those are dichotomous events. One of those two things must occur. It must either rain today or not rain, as in you'd say, oh, today it rained or today it did not rain. One of those things must be true because either A or not A will happen. Next, let's continue on. Got maybe some people watching. So we've got the probability of A or B, the probability of A or B. So with this right here, let's highlight it. This is something we did earlier, and I wonder if I still have it up, because we did some really good stuff, and I think we do right here. Wow, and I've got it still right here on the screen. Awesome. So what I've highlighted right here, just happened to be, is the probability of A or B. And this is the addition rule. Things must be disjoint. Disjoint means mutually exclusive. We were talking about that earlier today, so make sure you ask questions. You understand what it means. But when you have two events that are disjoint or mutually exclusive, you can simply add them up. And it's a very easy add because we can just, they don't overlap. I'll kind of show you what that looks like right here. Let's grab a new sheet of paper. When you think about disjoint the following way. Disjoint is like two circles that look like this, where you have A and you have B. There's no overlap between A and B in disjoint events. So this is disjoint, which is the same thing as mutually exclusive. And then when you have not disjoint looks like this. Now there is a region, it's like a Venn diagram. There is a region on here where A and B also occur at the same time. So you have an area where A and B occur. So this is not disjoint. Remember that disjoint is mutually exclusive. Think of which circles are exclusive of each other, mutual meaning the two exclude each other. So the top one is mutually exclusive, which is also disjoint. Think there's no joint to that circle, where this one down here has a joint. And they're also mutually exclusive of each other. They exclude each other. So just kind of hone in on what those words mean. Are these circles disjoint? And then think about what disjoint means. There is no time when A occurs and B occurs. But if they are not disjoint, then there can be a time when A occurs and B occurs. An example of not disjoint events would be like making an A on a statistics test and making an A on a chemistry test. You can make an A on both of them, so they are not disjoint. But an example of a disjoint event would be like making an A on your statistics test and on the same test, the same exact test, making a B. You cannot make an A on a test and a B on the same test if you are one person. So when you talk about one test, you'll get one grade. So either make an A on your test or a B. You can't make both. They are disjoint. But if you talk about a statistics and a chemistry test, the lower example, you could make an A on the statistics and an A on the chemistry test, and so, or a B or whatever other grade, and so those are not disjoint because they can both happen. So that is the addition rule in action right there. Let's hop back to the formula sheet. And if anyone hops on, feel free to ask questions. We've got here the next one, which looks to be the multiplication rule. You even get the rule. Oh, that's so awesome. Look, here's the rules right here about when you add things together and multiply. We've got it on the formula sheet to help out. So now we've got the multiplication rule right here, that when two events are multiplied, they need to be independent of each other. You even see the words that I use. There's the words for both of these. There's the sign, and here is the rule we use. So you've got the addition rule and the multiplication rule, and all of this goes right back here to the sheet I created earlier today, and I've created many times to review the topic. Now it looks all crazy. We'll click over here. So this little diagram right here, knowing how it works and knowing if you're using the multiplication rule, well, obviously you're multiplying, they need to be independent, and the word you'll use is and. So key stuff right there. You'll do the following. And you see the complement down below, which we've already seen on the formula sheet too. Next, let's take a look at the remainder of here. We get into the sampling distribution of p hat. This is chapter 13, the first part of it, and the next part is the second part. And what do we see? Let's zoom in really big so everyone can know exactly what I'm talking about here. Aha. So we have first that the mean for the distribution of p hat is equal to p. So it's important we can identify what each one of these are. The first one right here is the mean. This right here is the mean. This right here is the sample proportion. And this right here is the true proportion. Now, if you try to make it make sense with that, it's a little confusing. Let's talk through some examples of this. What you're actually saying is, when I take a sample proportion, I expect to see the true proportion. So what do I expect to see in my sample proportion? My true proportion. That's what you're saying. And why does that make sense? It's like if you know, and I always talk about Taco Bell. I really want some Taco Bell now. If 70% of students like Taco Bell and you took a sample. Now, what did I just tell you when I said 70% of students like Taco Bell? I just told you that. 70% of students like Taco Bell is the truth, apparently. I never gave you a sample size. I said 70% of students like Taco Bell. And from that, that would make that P, because that is apparently the truth. And so now we need to find out the mean for the distribution of the sample proportion. What does that mean? It means if you were to go out and take a theoretical sample, what would you expect to see? And let's look at that. Well, in the middle of the distribution, you expect to see P. So what would you expect to see if you took a sample of students and asked them if they like Taco Bell? Well, I'd expect 70% of the students to like Taco Bell. And look, I don't even have to give you a sample size. I can just go out and say, if 70% of students like Taco Bell and you take a sample, what percent of your sample would you expect to like Taco Bell? And the most likely percent is 70%. Now, obviously, there's variation, and we're right about to talk about that. But right now, we only know the mean of the distribution. There would be variation because it depends on how big of a sample we take. So we need to find the standard deviation, which is the variation. That creates these little tick marks here going up usually about 3 for 3 standard deviations above the mean and 3 standard deviations below the mean. Just tells us how far out the curve spreads. There are standard deviations beyond that, but it's rare to see things outside of 3 standard deviations, the 68, 95, 99.7 rule. So standard deviation of p hat. This is basically the variation. If you were to tell someone what it meant, you would say, this is the variation we expect to see in the distribution. So think about this. What changes the variation in it? Well, we'll do 2 examples right here. You could have, in one instance, a very large n or a very small n. So we're not actually going to solve the math, but look at what happens because n's on the bottom. If we have large versus small, you'll be able to see up there. Large is going to make the distribution really tight, and small is going to make the distribution very wide. So what n does is it makes the distribution tighter, and we'll see this in later chapters, like chapter 14. But just think of this mathematically. Since it's on the bottom, you're dividing by it, and the distribution will get tighter. Now, both of these, with my Taco Bell example, are going to be centered at 0.70, and they'll have 3 standard deviations. Both of them will have 3 that'll go across the whole curve, or the kind of what we're showing right here, which is the bulk of the curve. So both of these would have 3 standard deviations on the curve with the 68, 95, 99.7 rule applying. So let's make sure everyone knows what the notation is here. This just tells us the spread of the curve. It helps us draw the standard deviations on it. So this is the variation in the distribution of the sample proportion. And so the notation on this is the sample size. A question would say if we went out and spoke to 100 students, n would be 100. And then we have here p. In my Taco Bell example, here I'll circle p and q. In my Taco Bell example, p was 0.7 because apparently, and this is the true proportion, it's the true proportion of UT students who like Taco Bell, and the truth is 70%, so that makes it p, and then q would be 0.30. So if p is equal to 0.70, q is equal to 0.30. So we have p and q here, and then we multiply them together. Remember, p times q over n square root. And we even give you that q is 1 minus p. Now, we are not actually using p hat much right now. We'll use it in a second. But p hat is the sample proportion, and p is the true proportion. What's the difference between those? Well, a true proportion is like, it is true that 70% of UT students like Taco Bell. A sample proportion, which we're not working with right now, would be, I spoke to 100 students, and 80 out of the 100 like Taco Bell. So we can solve for p hat there. This formula is not on the page. It's not a very tough one, but I'll write it down for you. The formula there would be x over n equals p hat. And so what you heard was 80 out of 100 students. And so p hat, the sample proportion, and just think about it, 80% of my sample like Taco Bell. And this is from a sample size. Now, that's not the truth. That's in a sample, I observe 80% of the students liking Taco Bell. We can then ask if that's unusual. To ask if something is unusual, we turn it into a z-score. So this means right here, just the z-score for the sample proportion. We're going to ask how unusual is it? To find out how unusual something is, I want us to focus in on what the z-score formula is. So I'm going to scroll down the page just a little bit right here, and let's think about what it does. The z-score formula just tells us how unusual something is. All we do is take an observation minus what we expect and divide by some sort of standard deviation. So if you notice, we're just standardizing a distance. That's all these test statistics are. They're a distance standardized. So our difference or a distance. You notice up here it's a difference between the two things. What do we observe and what do we expect? And then we divide it by some standardizing thing for the problem, and then it turns it into a standard test statistic, which is a standard unit of measurement that we can compare things on. That's what z-scores are. You can be like, a z-score of 3 is very large, a z-score of 4 is even larger. They're unit lists. They allow us to compare things. So let's think about what we have right here. We need to solve our Taco Bell problem now, because in our sample, just this made-up problem I made up, 80%, you notice that is p hat right here, 80% of my sample liked it, and we expected 70%. So you notice all that's going to get me is the difference right there. That is just how far or away are those numbers. So they're 0.1, that's the difference. The z-score is going to be positive. But on the bottom here, now be careful, the bottom you have to use p times q over n square root. And I think that's where people make the problem. They entered into their calculator wrong, where they use p hat instead of, oops, it was not supposed to scroll up. It's going to do that every time I do that now. Can I get rid of that dot? There we go. I wanted the dot to be there. That's what I pay. That is p hat. I mean, that is p. I'm like, don't make the mistake, and then I'll make it. There we go. What I'm doing right here is I'm solving this formula right over here. I'm just doing it in a blank space. But this is the formula for the z-score right here. And if you notice, I've solved the standard deviation on the bottom, because all you're doing is on the bottom of this curve, taking and putting that standard deviation down there. So this is the standard deviation. So that's the standard deviation. We'll do eraser. Of course, it's going to do that. And then this right here, this is p. So this is p, and this is p right here. It's important to know what goes into each part of the problem so you can make sure to do it correctly. And there we go. And so this will get us the z-score. We can ask if this is unusual now. And so let's solve it. So the bottom is p times q over n square root. And that's that. The z-score is going to be a little bit more than 2, which is kind of unusual. And then we get 0.10. That's because 0.8 minus 0.7 is 0.10. We divide by and we get 2.18. So a lot of your homework assignments might have you put this into the David M. Lane and ask you the probability of this, because this is now a z-score. You can put it into the David M. Lane. I think I still have that webpage up. I do. And since it's a z-score, we'd go over here. We'd put in a mean of this and standard deviation of this. And we'd go above. It's going to be a little bit, it's going to be about 2%, or no, I'm going to say 1.5%. 1.5. Was I close? It rounds to 1.5%. There we go. We got it. So 1.5%. Rounded up. I knew it rounded up. So that's what you do with the z-scores. You can find out how unusual something is, and that was pretty unusual. Usually we like to make things very unusual. So usually really big z-scores or very small z-scores. Like if we're going to make it unusual, we're going to make it more unusual a lot of times. So that is how you use the z-score, and the z-score tells you how unusual something is. Then we have a confidence interval right here. And confidence interval questions pretty much are questions where we give you the z-score. We don't expect you to memorize them. If you're doing homework problems, your classic z-scores are as follows. 80% is 1.2818. 90% is 1.645. 95 is 1.96. Every statistician knows that. 98, you'll see something interesting here, 2.3263. Maybe you can figure out how I figured out that last problem, how I got a good guess on it, knowing these z-scores. You might be wondering, well, how did I do it? Because my numbers are a little bit different here than what I told you a moment ago. When you make a confidence interval looks like the following. A confidence interval shades the middle, so you actually get, if you make a 98% confidence interval, so if this is 98%, then you'd have 1% left over here and 1% left over here. So that's how I was kind of using these guesstimate things before to use this number to know it had to be above 1% but less than 2.5. So if you're wondering how did I make that guess a moment ago, I actually used z-scores I know from confidence intervals to say, I use basically your empirical rule tricks we do, and I was like, okay, it has to be between 1 and 2.5%, and I was kind of like, I've done this a lot, so I was like, yeah, 1.5? And so you can get good guesses on it. So this right here, everything I'm talking about right now is the z-score. The reason it has a star is because you get to pick it. You can pick any level of confidence you want. You can make an 82%. You can make a 1% confidence roll. It'd be like a z-score of like 0.1. It'd be ridiculous. I'm 1% confident that the true proportion is contained in the interval. That'd be ridiculous. So the z-score controls the confidence level. And what else do we have? And if you're in here, feel free to ask questions. We have a few viewers. So that's the z-score part of it. The last part is just the standard error of the interval. The last part right here, you'll see that we have here p hat times q hat over n, very similar to this, but it's using p hat. The reason is we don't know p here. We're making a confidence interval to estimate the true proportion. So we do p hat times q hat over n square root, and that gives us the standard error of the interval. And then what else do we have? It's going to scroll back up on me. Down here, one more time. There we go. We also have p hat right here, which is also the sample proportion. P hat's the sample proportion. In a question, you'd hear something like 80 out of 100 students said they like Taco Bell, and that would make it 80%. Once again, this is the formula x over n to get p hat. So x over n is equal to p hat. And then q hat, once again, is so 1 minus p hat equals q hat. So pretty easy right there to know which one is which. Just make sure you remember that p hat is for a sample proportion. The hat actually means estimate. So when you think about y hat, that's the estimate of y, and y bar is the mean. So sorry, I'm going on a tangent right there. One last thing I want to talk about with confidence intervals, and thank you for anyone watching this. People might be watching in the future right here. Whoops, didn't click the eraser. Let's see right here. Let's talk about this. So right here, what do we have? This is very important for the remainder of the class because every confidence interval has a center and then has plus or minus a margin of error. Now, the margin of error has two parts of it in our class. We always use kind of these symmetric intervals. So the margin of error is going to be some sort of test statistic. So we'll write test stat here, and then it's going to be times some sort of standardizing factor. So we usually times it by a standard error. So you can actually see these three parts in the confidence interval. You've got part 1, part 2/3 right here, which is there. And let's erase this. And then you've got right here part 1. Oh, excuse me. This is all in the margin of error. I hate that it does that. I wish it would never do that. Part 2 and part 3. And so this is part 1 right here, part 2, and part 3. Now I mentioned this because we'll be doing more intervals soon. So when we think about what other intervals there are, we can write some other intervals right here pretty quickly. You can just do an interval for like guessing how much money you'll make. You'll say, I'll make between $60 to $100. Well, that would be, if we did that interval right quick, look at the formula right here, how we write intervals. A center plus a margin of error. What's the center of 60 to 180? The center is 60 to 100 is 80. The center of 60 to 100 is 80. So let's just go here and put 80 at our center and then go plus or minus 20. And what does that make? That makes an interval from 60 to 100. But when we look at this, we won't always use it that way. It's important to know how it works. I'm over here on this screen now. What we will be doing a lot of times, where am I? Oh, there we go. It just did not want to zoom out. We will be doing formulas like the following. Hey, what's up, Andrew? Good to see you in here, Andrew. We're just talking about the formula sheet. So good to see you. I've got the chat over here. So hope you're doing well, Andrew. Andrew, if you have questions, feel free to ask. I'm just chilling out. I'm going to start doing Twitch, I think. How's the volume and everything? So good to see you, Andrew. So Y bar. Oh, and if you guys have questions on 320, ask those 320 questions. So look at what we got here. That is a confidence interval for the mean. And let's do another one right here. So I'll erase this. But if you have questions, feel free to ask. I'm here to answer questions. So sounds good. Volume is good. No echo. Awesome. Let's draw it out right here. How are you doing, Andrew? Whoa, that opened up on the top screen. That is so weird. I'm going to draw another confidence interval right here. We're going to do y bar 1 minus y bar 2 plus or minus, that's the margin of error, t star df stands for degree. Oh, I forgot to put n minus 1 down here. There we go, n minus 1. And then square root of s sub 1 squared, and we will give these on the later test. These are not on this current test, but if you notice, it follows the format right here. N1 plus, there we go. Those are the final 2 confidence intervals for the test, for the third test. But if you notice, they follow the same format of we have the margin of error over here. Everything after the plus or minus is the margin of error. So these are all the margin of errors, and the margin of error has 2 parts. Part 2 right here, and part 3, whoops, looks like in the wrong. I'll erase it. But if you have questions, Andrew, feel free to ask. We're just chilling out. Got 4 viewers. If you're hopping in, say hey, ask a question. I've got the chat up so I can see what's going on. But this is what's going on, and I've highlighted the other interval. But that does it for the formula sheet. So if you have questions, if you want me to work a problem, if you want me to show how to do anything, feel free to ask. I've got tons of capabilities right now. I'm just here to help. I got an echo on my computer, but now my phone. Maybe you have 2 streams open. I hope there's no echo. I listened to it earlier. I have to listen to it on my computer. Could like run out in the main room and like rewind the stream and be like, is there an echo? Am I hearing an echo? So do I have, oh no. Oh, I might have echoed the whole stream. Was there an echo the whole time? Andrew, I think I had an echo the whole entire stream. Oh, it was you? Make sure I've got... No, I might have had an echo the whole stream. Let me open that back up and see if it is. Let me see. No one was here to tell me like, hey, you're echoing. Let me see if I play the stream. Oh, okay, good. Okay, I'm going to play the stream in the background right now, and I'm going to see if it echoes. I'm going to see if I'm getting any other audio. Okay, good. I'm not capturing desktop audio. Cool. Awesome. Yeah, it looks like maybe you had me. Awesome. Yeah, maybe it looks like it's not. I wasn't causing an echo. So that's awesome. Let's see here. We had a few viewers in here. But if you have questions, Andrew, feel free to ask. I'm just chilling out right now. Stream health 6? What does that mean? How's 320 going? If you got questions, feel free to ask. I can work on any problems for that or whatever you guys want. Just relax in and stream it for the moment. Oh. It's weird. It's like I see you guys through this now. I've got screens here and everywhere. You can't see where I'm pointing, even there and everywhere. We'll see if anyone has any questions, feel free to ask. I might hop off here, but I'm going to try to set up Twitch, Andrew. I think, have we talked about Twitch much? I might try to set up Twitch tonight and just say like, heck, I'm doing it. I'm going to jump on Twitch and stream on Twitch. Yeah, I can see that. That it's, and that's why maybe just asking questions, like, oh yeah, Twitch is just like this, but it's like even more for streaming. So I'm really excited because we've got the channel set up, and yeah. So the good news is, especially when I stream this, you can watch, like you can have the window open. Twitch is totally for gamers. Twitch is all about gamers. Twitch is like gamers. So like I feel like I should get a Nintendo and hook it up to this and start playing like old Nintendo. I don't know. I mean, what else am I gonna do? Just I mean, I have a Nintendo, but I don't have a capture card for it. I wonder. Huh. I bet there's a way. There's a will. There's a way. So, me like just start playing Mario on Twitch. Be fun. Be interesting. Like Stat201 playing Mario. But I don't know. Do you have any questions? Or we've gone through the whole formula sheet. So I wanted to put this out there tonight so people could see it and go over the formula sheet. With counter to get dual screens and my computer cannot open a lot of apps. Whoa. So wait, you're building a computer and I've got 3 screens right now. So I've got the stream up here on like a screen, then I've got the chat window, and then I've got my tablet. So the tablet's one screen, and then I had a problem with capturing that took me like an hour to figure out, that I wasn't able to capture windows because I wasn't in the video card. So yeah, build a really cool computer. That's a lot of fun right there. So I've never done a 3-screen display, and it's pretty crazy. It's like, what is going on? Why are there 3 screens? Yeah, the neat thing about this screen over here, what you're actually watching right now on this, is the tablet screen. And so I use this because I can draw on it. So it's just a full screen. It's probably like a 27, 32-inch screen, and I can just completely draw on it. And it's a huge help. And so then anything I want to display, I put down here. And so I can just go down here to the web pages or whatever. And I need to get, I think, and I saw it just recently, that there's a thing where you can annotate on screens. I should, like, another educator showed me it, and it was just by happenstance. And they're like, I'm not good with tech, and I was teaching them how to like teach online. And then they're like, I have this thing that lets me draw on anywhere on my screen. And I was like, wait, what? I was like, I've been looking for that. I don't know if it's free or what, but it's just like it brings up a pen and you can just annotate on the screen. Because right now my pen just moves the screen. So it's pretty nice having all the screens. I don't know. I need to set things up better, but I want the green screen here. I want to just be everything. Your Galaxy, not Pro. Yeah, it's pretty crazy, all the tech we have. Just like, I never thought growing up, I couldn't imagine a computer like this. Like, regular iPad. It's really nice, like iPads and stuff like that, and what you can do, like extending displays and stuff like that. I just never thought, like, I don't know. I grew up when very few people had computers, and now I've got a bunch of computers. So most people have I shouldn't say most people have multiple computers, but a lot of people have like multiple computers. It's like, oh yeah, I've got my desktop, my laptop, my parents have a computer, I have a computer, my brother has a computer. It's like families have a lot of computers, I should say. Because growing up, if a family had one computer, it was a big deal. It's like, oh, you got a computer? What kind of computer you got? And now if you're like, I have a computer, they'd be like, yeah, most people have a computer. So, and I mean, our phones are computers. So we should be like, we have multiple computers, I think. It's like, it's pretty crazy. And then the iPad's a computer. So it's like everything. Yeah, you just need one good one. That's the way it is. It's like having one really nice one. And this, that's how I'm able to do what I'm able to do now, because this computer is really good and allows me to stream it. Yeah, that's easy access right there. That is easy access to it right there. So yeah, no, it's as long as you have one good one, it's really nice. And that's, like, I'm glad you and Connor are building one, because that'll really, like, it just helps to have a really good computer, good, like, if you put a good, whatchamacallit in it, can't even think of what it's called, a good graphics card, everything like that. Let me try this. Do you think I should bring the microphone up or down? Yeah, I think desktops are where it's at, because you can put a good graphics card in it. And I'm going to look at the audio here. It looks good. Looks like I've been doing well on the audio. Well, I want to improve it a lot. I want to make sure everything sounds great. Because I listened to it earlier and I thought it sounded a little bit loud. But I think I'll be back online. You'll see me a lot online, Andrew. Pop in, say hey. We missed you in class, Andrew. So I know you're in 320 right now. But stop in anytime. Just come in to say hey. Be like, hey, Brian, what's up? And I'll be like, hey, Andrew. Yeah, I'm totally not in the studio. I'm at my place, so that's why everything looks all, but awesome. Thank you so much for like signing up to the channel. And guess what? I think tomorrow I'm going to monetize the channel. So if you get a notification tomorrow, check it out, because I don't know what's going to happen when I monetize it, but I'm going to monetize it right before we do all our streaming, which could be a good idea or bad idea. But I think YouTube will see like the burst in like people watching the channel and be like, oh, people should watch this channel. But I can't put ads before our class videos. I'm not going to do that. I'm going to put ads on other videos. So monetize, and what it is I've been asking UT for a long time if we can monetize the channel. It's been like a thing we've been talking about for, I'd say almost since as long as I've had the YouTube channel. And I've had to learn about monetization. what we want to do with it is when we monetize the channel, we can actually make a little bit of money off the channel. Not a lot. I think like each year we'd make a couple $100 most. And I say we because I want that money to go back to UT. I want it to be used for like tutoring or pizza party. We can all see each other. But I want it to go to students. And so some of the videos I put up, I'm going to put ads on them, but not the ones people like primarily watch. I know that sounds weird, but I'm going to put it on like probably like chapter review videos that are not the lecture videos. Like I'm never going to monetize lecture videos because I don't want someone to watch the lecture and I can choose which ones are monetized, but I don't want someone to click to a lecture and then they have to wait through an ad to watch me live. I want, if we have like a review video that other classes might use, like across the nation, I want us to be like, hey, here's how to do a t-test. Here's how to do this. You can put them on old videos, and that's the goal. I've got a bunch of old videos where I talk about how to do a t-test, a 2-sample t-test. I think you can put it on even old videos, but YouTube might go towards, newer videos. But during this time, I thought it'd be a good idea because we want our videos to get out there. I have a bunch of really well-produced videos. So I'm like, hey, I can monetize those videos now, and we're not going to put it on like the current lecture videos. So that way students who are trying to learn the material right now would not have to sit through an ad. I don't want them to be like, I'm trying to learn, I have to watch an ad. And you can choose how many ads go into videos and stuff like that. I have to learn a lot, but it'll also grow the channel. So here's the biggest thing. Is YouTube does not really promote your channel unless they can make money. Because let's say YouTube has 2 channels. They have channel A and channel B. Now, channel A has monetized itself and channel B has not. And they both make the same exact content. So it's the same content, but one channel, I think it's this channel. No, it's this channel over here. Channel A has monetized itself and channel B has not. So which channel will YouTube promote? YouTube will promote the monetized channel because they can make money. So when it comes to advertising a video that they say, hey, you should watch this video, YouTube will put up the video that's monetized because they want to make money. I mean, makes sense. They're like, hey, I can make money off this video. Let's show this video to people instead of this video, like suggest it. So we're more likely to appear in suggested videos, all these other things, because we're monetized. So I'm going to do that like tomorrow morning and start going through monetizing videos. And then when I go live, I'm going to see if it has an impact. Like all of a sudden, if like maybe random people will start being like, hey, hopefully it's not crazy. We've got a lot of mods, but it'll be interesting. And you can unmonetize your channel, I think. You can turn monetization off. Exactly. I've worked so hard on like TI videos, and I'm like, why do my TI videos not show up? Because I've got these really good like TI tutorial videos. And then I talked to some YouTube people, like people I know or people I've come in contact with, and they're like, yeah, you need to monetize your channel, and then YouTube will start advertising your videos. YouTube will actually try to get people to watch your videos. If you're not monetized, you can make good videos, and YouTube will just be like, we got other people we can sell, like make money off of by showing ads in front of their videos. So I'll probably go in and monetize all like the TI videos. And they're very short videos, which is kind of a bummer because it's like a 40-second video and you have to watch a 15-second ad. But all that money that we get from ads will go back to students. So that's the goal. Exactly. It's like Google algorithms. And once again, just for anyone watching this in the future, if you're like, wait a minute, this was a video on, the sheet, we're just here talking now. What it is, I'm not going to take any of this money. We're going to put it back to students. That's the goal, is that we want students to get tutoring. We want, did I say something or do you say something? I'm like, wait, what's the whoops? We want the money to go back into students. We want, it to go to tutoring. We want it to go to like events, like pizza parties, like I said, when we can all finally see each other again. And so we want it to be a really positive thing. And, people are already making content, and we're not trying to like sell it to people. We're just saying we're going to put an ad before it. So it's, and then we take that money from the ads and we put it back to students. And then also this helps us grow, which means more money for students. So that's my goal. And if one day, if we started, let's say this just like goes crazy, I'd love it if we had like the Stat 201 scholarship and like we could give like a student a scholarship. Like what if we pulled in like $50,000 a year? We could just like turn it into scholarship money. So that'd be amazing. Like, oh, we use the YouTube channel money for scholarships. That'd be awesome. So, the dreams we have. So we can look back on this video like 5 years from now and be like, wow, that's when he was talking about monetizing. And that's when they came up with the scholarship, and, fingers crossed. But I know. And then pay the tutors and all that stuff. Like that'd be really, if we just pull in a couple hundred, that'll pay tutors. Also, Andrew, if you know of Twitch, now you don't have to do it for me, but when we go over to Twitch, there's Twitch Prime. And so if you have Amazon Prime, you also have Twitch Prime. And that means you get a free subscription to someone on Twitch each month. So when I go over to Twitch, I don't know if I'll have the sub button yet. I hope I do. And I have to look through like, that'll be interesting. I think I'm just going to hop over to Twitch and do it and make sure everything's all working there. But if we have people subscribing to us on Twitch, we can actually make money off of that too. And then that'll do the same thing. So I might try to like stream on Twitch. Yep. So, and it's free for people with Amazon Prime. It's your choice. But anyone can, yeah. So if anyone wants to do it, they can. And if word gets around, could you imagine if like every UT student did that? And once again, we just put the money back in. If we just told all UT students like, hey, if you want, do this, and no one has to. But could you imagine? I think you get like at least like $2 from it. So imagine if every student did that, and then we just took that money and just gave it back. Because I mean, that's what I would do with it. It's just like, I don't need it. We'll just use it for good things. We'll just use it to help students. So we spread the word around. We're like, hey, go do this. And then, well, right now there's only 2 people in here. So right now it's just you and me. We'll see how it goes tomorrow. I'm hoping we get our usual attendance of people tomorrow. I was setting everything up all week. I mean, I literally have like I've got everything. It's pretty nuts. So, it's pretty interesting, and I'm hoping it looks, I know I'm not in my usual, like, standing right here. I don't have to get a standing desk when I set this up in location 2. But it kind of shows me what I'll need to do for the future when we do it in Texas. So, which is kind of cool. It's kind of a test run of Texas, but I haven't created this room for that purpose. So it's kind of a put together studio on the fly, which still took like 10 hours to put together. Oh gosh. I am glad I've spent a lot of my life setting up electronics because a little too much light. Oh, cool. Here, wait, watch. Let me turn down the light. Let me change that. Turn down light, not up. Okay. Okay. Is this better now? I guess now it actually looks more like natural skin tones. The sheet's not as lit, but I'm not doing a green screen. So... This is too funny, Andrew. It's it's not as much as a shadow, yeah. It looks like more natural skin tones now. Like I actually don't look so illuminated like crazy. It's yeah, I've got lights in here. I've got LED lights and all that stuff. So I might turn it up just, you think, so I've got the overhead light on. I've got so many lights. I need, like, everyone's got cool stuff. Like I look at like Mitch Flower Power and he's got like cool stuff in his background, and I wish I had a green sheet to hang up so I could do like the green screen and just be a floating head down here, and then I'd have to worry more about how that's lit. But do you think this looks better, Andrew? You think I should turn the lights up or down? What do you think? You can be like, turn your volume up, turn your thing down. Paint? Oh, paint. If I put paint on this, it would just like fall immediately. It'd be way too much weight on it to put. It's just like, it almost looks like it blends in with the paint green. I should just like, I don't know. I might one of these weekends get really adventurous and just like reset up this room, and who knows, just like be like, yeah, I'm not doing much this weekend. Let me just reorganize this whole room so it's literally like a studio, to where, you know, like, oh, what if I did that? What if I bought green paint? That'd be crazy. That'd be nuts. I don't know. I'm in quarantine. Nobody can see me. I have put myself in quarantine, so it's, there's a bunch of good video games. Ori and the Blind Forest just came out. I'm thinking of John. Hopefully, John's in the in-class. Get to see him tomorrow, maybe. He and I have talked a lot about video games in office hours, so shout out to John right there. It'll be good to see all my students again. Like, man, Andrew, like, it's so, you start off online, but I get to meet you guys and gals, and then I like, get to know you and get to know what you like, and like you and Connor and John and everyone comes to office hours, and so then it's kind of a bummer because don't get to see everyone in office hours. And I mean, the office hours we have are pretty awesome. Like, it's busy, and I like that, and it's so quick. It makes the day. I'll go into office hours at like 9 or something like that, and then it'll be like noon. And I'll be like, what the heck happened? I'll be like, it just like immediately we were done, right? And then, well, no, you're still gonna take 474, right? You're still gonna take BAS 474 with me next semester, so it's gonna look even better than this next semester. Like, we're gonna have a lot more going on. We're gonna have a lot more cool stuff. Yeah, no, totally. And I'll be doing more stuff like this, like, and I'll still, hopefully, as long as everything gets back to normal, I'll be flying and doing all that stuff. And so, yeah, it'll be, we'll try to get back to, normal doing of stuff. And I know it's crazy, and yeah, but no, you're doing a great job, Andrew. And if you have questions on the assignment, just feel free to ask anytime. I might hop off here, eat a little bit of dinner, but hopefully this helps people with the formula sheet. But Andrew, swing by anytime. Maybe if you guys want, I can do stuff for I can do anything for 320 if you guys want. I teach the class, so I've kind of been the coordinator. I helped out this semester with getting them going, but they've done an excellent job. So congrats to everyone in 320 who's running the classes. Excellent work. And so, yep. Nice job, Andrew. Great. You're a smart guy, and I'm proud of you. It's you and other people like Gavin and other people who are just working really hard, and Raj. So, he's getting a shout out now, but, you guys are working super hard, and I really appreciate it. So, but yeah, if you have questions on anything, want to understand topics a little bit better, like RMSE or standard error or multicollinearity, any topics like that, just be like, hey, Brian, I want to know about this topic. Can you explain it? And I'll hop on here, because I'm just going to do as many streams as I can. So whenever you guys want, feel free to ask. But I think that's got it for now. So we'll play the Rick and Morty outro. So I will talk to you later, Andrew. I'll probably be online. Swing by anytime. It's a good deal, and I will see you around. See you later, Andrew.
Like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.